Hi, welcome to Futureproof Your Planet, our Sustainability Master Series, and this is our last episode for civil engineering. Today I'm joined by Dr. Elizabeth Lewis, who will be filling in for Claire. Do you want to tell everyone about what you do?
Sure. Hi everyone, I'm Liz Lewis. I'm a senior lecturer in computational hydrology in the Department of Civil Engineering and Management. My research is all about how climate change is impacting floods and droughts and the modelling and tools that we use to be able to predict and manage that risk.
Thanks. You'll be watching a video on how climate change affects our water systems, and afterwards we'll be doing a Q&A, so you can put your questions down below and we'll be answering them.
I'm Claire Hoolohan. I'm a researcher at the Tyndall Centre for Climate Change Research and a senior lecturer in civil engineering, where I teach undergraduate students about sustainable and resilient infrastructures. My research is about water and the environment and how we can future-proof our planet by working through the intersections between water and climate change. So water is one of the first ways that people are going to experience climate impacts in their day-to-day life, whether that's dramatic events like flooding and drought, or more mundane things like water scarcity, or just big changes in the weather. These are kind of the first material ways we'll experience climate change in our everyday lives, and that's true for most people across the world. What we're finding is already there is strong scientific evidence to show all aspects of the hydrological cycle have been impacted by climate change. We're seeing an increase in rainfall in most places, and at the same time seeing a decrease in rainfall at times when it matters. We're seeing like an increasing extremity of the extreme events that we get. So floods are getting more extreme, they're coming more frequently, and they're affecting more areas than they have done in the past. The same is true for water scarcity. So it's affecting more regions, more people, and a greater magnitude than it ever has before. And these are big engineering challenges, whether it's traditional engineering solutions and thinking about how we rethink structural engineering approaches like building flood defences, or whether it's looking for innovative new solutions in blue-green infrastructure and things like this as ways of addressing multiple challenges all at the same time. So this isn't just about changes in rainfall either, it's about changing the way that people use water in everyday life. So whether it's about more water for agricultural use as we experience hotter summers, more water for industrial processes as we bring on new ways of manufacturing goods or producing different services in society, or if it's about how we keep our populations cool and our bodies cool as we're experiencing warmer, hotter summers. So it's these sorts of changes, both in the sorts of climate impacts we're going to experience, but also the way that society is developing and placing new pressures on our system. It's these multiple challenges that we're going to have to learn to compensate for. So there's two main challenges that we're interested in. The first is water scarcity and the second is flooding. So water scarcity is a relative measure. It's about balancing water demands and water supply so that there is enough water in any given time in any given place for all of the demands that it's needed for. If either water supplies decrease or demand increases, we end up in a situation where we've got water scarcity. And presently, as we're experiencing more warming, both of those trends are going in the wrong direction. Today, about half of the globe's population experience water scarcity, whether that's just for some part of the day, some part of the year, or all year round. About half of these people live in India and China. So we're not seeking a one-size-fits-all solution here. We have to recognize different kinds of water scarcity and different extents of water scarcity. And we also need to recognize the different needs that different communities have in different places around the world. It depends on the people and what the sorts of needs that they have of water systems at a given time are. And it depends on the types of environmental conditions in any given area. Water scarcity impacts drinking water supplies. It means there's not always a clean and consistent supply of water coming into people's homes or businesses. It impacts health and sanitation. It affects rural livelihoods, affects urban livelihoods. And it also impacts food supply systems, meaning that water scarcity experienced in one place can have ripple effects all over the world. And ultimately, climate change is making water scarcity worse. So it's important that we're building engineered systems that work for today's population's needs, but also that we're thinking about future-proofing these systems to changing climatic conditions. We need drinking water systems that provide consistent, clean, good quality water for all of the population. We also need to be thinking about future-proofing these systems for changing climatic conditions. We need to make sure there's enough water for people to drink, for health and sanitation services, for agriculture and for industry. But we also need enough water continuing to flow through our rivers and streams that aquatic ecosystems are protected. To make things more complicated, at the same time as experiencing increased water scarcity, we're also seeing an increase in flood risk. Sea levels are rising, annual precipitation is increasing. The weather in general is becoming more stormy, and we're seeing a shift towards more frequent and more severe extreme events. This means that more places and more people are exposed to flooding than ever before. Globally, 1 in 5 people are already at risk of flooding, whether it's flooding by sea, flooding by river, or surface water flooding as water moves through our streets and urban spaces. In the UK, we're seeing an increased number of record-breaking events. These are becoming headlines increasingly year on year. It's not only a winter problem. In June 2024, heavy rains and thunderstorms had huge consequences for Italy and Switzerland as tourist resorts and towns were cut off by floodwaters. This all occurring in a period that is usually sunny and dry in these countries. At the same time, devastating floods in India and China have had profound consequences for people, for health, and for property in these countries. The built environment has considerable impacts on the way that we experience flood risk. So our drainage systems were built to handle a particular capacity of water, and that design capacity is being reached. Building on floodplains is becoming more common as population increases. And also the introduction of impervious surfaces into our urban landscapes is changing the way the water flows around these areas and introducing new risks to new parts of the population. Managing water crisis is one of the major engineering challenges of our time. And our research at the Tyndall Centre for Climate Change Research is trying to make sure that the ways that we manage these crises is contributing towards a low carbon, sustainable and resilient future. At the University of Manchester, we're interested in how we can inform policy to make these sorts of engineering projects as beneficial as possible. So we're looking at the interactions between housing policy and water policy to look for new opportunities for engineering projects. Our research in enabling water smart communities looks at how we can use integrated water management in new housing developments to reduce the impacts of flooding and think about addressing multiple social, environmental and economic challenges at the same time. One of our main areas of interest is around water reuse. So this doesn't receive much attention, but it's thinking about how we can use water, for example, water coming from our washing machines for reuse in the gardens. So it's about recycling rainwater and grey water for use again on the property. And in this project, we're interested in how to do that at development scale. So rather than a single property, we're thinking about looking at housing development in total, how we can apply measures there to be more cost effective and more environmentally beneficial. But there's considerable social, technical and policy challenges to enable water reuse in the UK. We need to find ways of effectively making sure that these systems are installed and maintained to a high quality. And who's going to take responsibility and ownership for these systems to put them in place and to make sure they remain sustainable over the long time. Our research is looking into the policy gaps and trying to understand how we can create space for these systems and the sorts of challenges that might be overcome in thinking about how people interact with them, how we make sure that they're maintained effectively, and whether people are willing and happy to have these installed in their homes. One of the other challenges we aim to address is around water demand. We're looking for opportunities to reduce water demand, find ways of becoming climate resilient that way. So in England, we have a publicly binding target to reduce public water supplies by 20% by 2038. And that's going to require considerable effort on the part of lots of businesses, the government and other organisations to find ways to reduce water in everyday life. Our research aims to understand variations in household demand. So trying to understand why some households use so much more than others, or why water demand is used more at certain times of day or certain times of the year. We look at trends in consumption and everyday life. So we're interested in things like hygiene trends, consumption patterns, fashion, gardening, to understand the impact that these have on the way that we use water in our everyday life, and more importantly, to try and identify opportunities to reduce water use. And then we work with industry, we work with policymakers to identify pathways towards these lower levels of water demand. The severity of climate change impacts depends very much on how much action is taken today to reduce greenhouse gas emissions and reduce climate change. In our teaching, we aim to ensure that our civil engineering graduates leave here with the knowledge and skills and the confidence that they need to go and make a positive change towards climate adaptation and mitigation. So I teach sustainable and resilient infrastructure. And infrastructure is fascinating because we're talking about designing things that will last in our environment for potentially hundreds of years. We're often talking about designing with infrastructures that have existed already for potentially hundreds of years. And those weren't designed necessarily to deal with the types of climate impacts we're experiencing now, and let alone those that are coming in 10, 20, 50 years and onwards. So one of the big challenges we face is trying to understand what is the future that we're likely to experience. How severe are those impacts going to be? What is everyday life going to look like? And what sorts of services will these infrastructures need to provide? So these are the sorts of questions that we aim to address. And we're looking for opportunities to learn about the sorts of changes that are impacting on our waste, our energy, our water, and our transport systems, but also learning about the kinds of measures that we can put in place to limit these impacts. We're interested in reducing the greenhouse gas emissions that go into infrastructure construction and design. So whether that's about reducing the use of materials like concrete and steel, which are highly emissions intensive, or thinking about entirely new ways of designing infrastructure systems. So thinking about nature-based solutions, blue-green infrastructure that works with water in the natural environment and natural green spaces to provide environmental functions without some of the environmental impacts of hard infrastructure projects. There's lots of different angles we can take in these projects, and there's lots of different challenges that we're aiming to address. But what we want to ensure is that people walk away recognizing the sorts of impacts that they can have to address climate change and sustainability. So this means we need to understand the future conditions in which our infrastructures are going to have to operate and the future sorts of services that they're going to need to provide. So we already exist in a situation with 1.1 degree of warming, and we're trying to understand what the consequences of 1.5, 2, 3, or even beyond that might have for our infrastructure systems. We're looking to understand the sorts of changes that we might experience in society and what that means for how our infrastructure needs to function. Engineers play a vital role in developing climate change solutions, whether it's about designing resilient infrastructures that last in the face of climate impacts, or whether it's about reducing the emissions involved in engineering projects so that we reduce the amount of climate change we experience. We can deliver the knowledge, the skills, we can give a background on climate impacts and the sorts of solutions that are coming through science today. But we're also looking forward to welcoming a new cohort of engineers that bring with them the creativity and imagination to think about what the next solutions might be.
Welcome back to our Q&A session. We're going to start off with the first question. What are some of the things we can do at an individual level to help with our water scarcity?
So quite a few different things that you could do to try and reduce the amount of water that you're using. Basically, just having an awareness about it to start with is probably a really great place to start thinking about things. So when you're in the shower, making sure that you're trying to use as little water as possible, like things like brushing your teeth, not having the tap running and stuff. But trying to build an understanding for how much water all your different appliances are using would be good. And then also starting to think about kind of the things that you buy and consume. So much like things have a carbon footprint with the amount of embedded carbon dioxide that they also have a water footprint as well. So you could have a look at kind of the water footprint associated with like the clothes that you buy or the food that you eat. And all of that will help kind of build an awareness as to how much water is actually being used by you every day, so that you can start to reduce some of those areas.
How exactly does climate change impact the global water cycle?
That's a big question. In lots and lots of different ways. So in kind of the water cycle, basically everything gets enhanced with climate change. So as it gets warmer, the ability for the atmosphere to hold water increases. So the atmosphere has more energy, and so more water can be held in there. Which means that there's a lot more drying going on, but also then there's a lot more water in the atmosphere, and you get kind of bigger, more extreme rainstorms as well. So we see kind of intensification of our like extreme rainfalls and storms, but we also see intensification of droughts and drying as well. So it sounds kind of counterintuitive that you're getting both drier and wetter at the same time, but that's a kind of our real big problem. So if you live in the UK, then you might have seen this summer has been like really hot and really dry, and we've gone into droughts, but then we've just had a really big storm that's caused lots of damage and flooding as well. So we're seeing these things kind of come after each other as well quite quickly, which means that our ability to be able to respond to these incidents is we're going to have to basically be better at doing that, and there's going to be more extremes to respond to.
What type of research is going into those types of responses to these weather changes?
Oh, tons. So loads. So a lot of my research is about trying to understand what they might be. So how big are our floods going to get? How much more frequently are they going to kind of come? Are there particular places where flooding is going to be much worse in the future than it is now. Especially kind of things like really extreme short duration rainfall. So that's something that's kind of emerging as a really important area, is these flash floods that can happen really, really quickly, and the water comes and moves through an area really fast. Are the most dangerous types of floods, so they're the ones that kind of lead to loss of life. So that's kind of like a new area now that we've got better, higher resolution data at kind of shorter and shorter intervals. We can understand these kind of like shorter, more intense rainfall durations as well. So that's kind of like understanding how the weather is going to change, but then we want to look at how we can actually manage those risks as well. So there's lots of research that goes into trying to understand where we should be putting flood defences, how we can manage those or kinds of flood defences that we do with like natural measures. So they're called nature-based solutions. So things like building ponds and planting trees and things like that, can they help us manage our flood risk too? And then also on the kind of drought and water resources side, there's lots of modelling that goes on to try and understand how water companies can best manage their assets and to move water around between different regions so that everybody has enough water to be able to drink and wash, and also for industry as well.
Thank you. What are the economical and political barriers to accessing clean waters, and how can they be overcome?
Also, another big question. Yeah. I mean, there are a lot. So there's lots and lots of competing interests around water. So this is one of the really, really difficult things about managing it, is that it's not just floods on their own and droughts on their own and water quality on its own. The whole water system is integrated together, which means that you have to think about so many different things all at once. So one of the big barriers to it is just there's a huge amount of people involved in managing water, and trying to get them to all talk to each other, use the same data, use the same models, understand how things are going to impact across all of these different systems is just an enormous barrier. There are hundreds and hundreds of different bits of government legislation that impact water in some way. And there's a kind of a big review of the water sector that's just going on at the minute, which is hoping to try and kind of consolidate some of that to make it a bit more manageable and practical to work with. But yeah, it's a huge challenge. So being able to kind of communicate and work together better is a big step to doing that.
How can emerging technologies like AI and satellite monitoring help us predict and manage water stress more effectively in the face of climate change?
Yeah, great question. So really exciting area of research is all around how we use AI in this particular area. AI's been shown to do a better job at modelling and monitoring lots of our kind of river flows, and all the research at the minute is trying to understand why and how we can use those models and kind of what we can learn from what AI can tell us. So yeah, lots of really exciting opportunities. Something that I'm looking at with my PhD student is trying to see if we can use AI models to reverse engineer some of the kind of missing processes that we don't really know about. So, you know, I was saying that it's like a really big complex area with so many things happening. We can't like monitor and track every single abstraction of water that like farmers are doing on their lands and stuff like that. So there's all these kind of things happening in the system that we don't really know what's going on, and we don't have the data sets for to be able to manage it. So we're hoping to use AI to be able to help us get back to understanding what is actually happening on the ground. So see if we can reverse engineer some of it to actually monitor some of these important impacts on the ground.
On the vein of that question, what exactly are you monitoring with these systems, and how realistic can they be to finding effective solutions to like all these problems? Yeah,
so we monitor lots of different things. So we've got kind of all of our weather that is driving a lot of the water cycle. So we monitor rainfall and temperatures and wind speeds, things like that. We have real-time data in our rivers, so we're always kind of checking on river flows. We have kind of boreholes with kind of measuring groundwater levels. We measure water quality. Like there are tons and tons of different measurements that we're taking that are kind of coming in real time. But one of the really hard things is that lots of these measurements have quite a lot of errors associated with them. So something that I research and that I care about in particular is rainfall measurement. So oh, I've got a fun fact. So with our rain gauges, we normally measure rainfall with a rain gauge, which is basically like a bucket, and it's got a funnel and it counts how much rainfall falls into it. So the area that these rain gauges cover across the whole world, if you got all of the rain gauges together, cover the area of less than half of a football pitch.
Oh, wow.
So yeah, it's super small. So we're measuring all these little tiny point measurements of rainfall across the world, and then with like big biases in where those gauges actually are. So some parts of the world, like the UK and America, have way more rain gauges than like big parts of Africa or South America. So there's that kind of bias, but then also the kind of quality of our measurements are really variable as well. So you kind of get big errors in rainfall data from like wind affecting it. So it blows over the top of these gauges and it stops rainfall from actually falling into the gauge. So our measurements can be like up to 40% wrong, which is like a huge number when we're like the basic thing that we care about with water is like how much water is coming in versus how much water is going out. If you're getting that kind of input, like 40% wrong, then it makes it really, really hard to understand all the rest of the system. So yeah, lots of issues with measuring data related to water.
You mentioned how there's very few of these gauges in countries in like Africa and South America. And do you think that might be part of the reason why there's issues with sustainability in different regions around the world compared to maybe what we know about what's going on in the UK?
Yeah, so I mean, there's lots of like, it's really, really complicated, kind of all of the politics and sociological aspects to kind of different management of risks. But yeah, the kind of data bias is definitely towards kind of northern hemisphere, more developed countries. And so that definitely kind of gives a bit of a bias into the science and the processes that have been kind of modelled and we care about. So it's quite difficult to overcome. But there are new different measurement technologies, so we've got a lot more satellites taking measurements now, so they cover the whole globe. So hopefully as we improve different types of measurements, we can try and correct some of those biases.
What advice would you give to a student who would want to study civil engineering?
So civil engineers are awesome. You should definitely study civil engineering. Civil engineering is great because you're solving real world problems. So it's all of the kinds of things that we really need. We need shelter. So we're doing structures and building buildings. We need water. We need clean water. So it's all these really practical things. Engineers are basically problem solvers. So practice solving problems, do lots of puzzles. Get good at maths. Maths is like your kind of fundamental, really important skill. It's also quite a creative subject as well. So you do lots of designing as part of it. So try and kind of explore your kind of creative side and your problem solving side whilst doing lots of maths at the same time.
Our last question. What career paths and specialisation do you think you can do after studying civil engineering, and how can that relate to sustainability?
Yeah, so sustainability is a huge thread throughout all of civil engineering. So in our course at Manchester, we try to incorporate it into all of our modules for civil engineering. You can go on to do so many different things. You can do structures, geotechnics, environmental engineering, water and hydrology. So it's a really great subject to do if you know you want to do something practical and useful, but you're not quite exactly sure what you want to do. It's a good place to start to go and do something useful in the world.
Thank you. Thank you, Liz. If you guys have any more questions, put them in the comment section and someone will come to it at some point and answer it for you. This is our last Futureproof video for this time round, but try stay tuned, check your emails. There might be other events going on that you should definitely join. Thank you.